This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we support design engineers and make lightning protection easy. You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Struck Aerospace Engineering Podcast. I'm your co-host, Dan Blewett. On today's episode, we'll talk about some hydrogen plans that Mitsubishi and Alaska Air are backing, some new foam system requirements for some aircraft hangars, because we talked in the past about how damaging a foam release can be to private jets, really any aircraft in a hangar. So they're relaxing some of those standards. We'll talk through that today. The potential for new air traffic control towers that are being needed, obviously an interesting problem because, things age, and we're getting to the point where many of them need some upgrades. We'll talk about Jeff Bezos' Blue Origin plans for a business park in space. And our eVTOL segment, we'll talk about the Jetson One, which is the fun, personal, anyone can be a pilot kind of aircraft. And then we'll talk a little bit about insurance and eVTOLs, how that they plan to insure these things. It's a great question as underwriters start looking toward this, the future of urban air mobility. So, Alan, let's start with hydrogen. So obviously we talked about this in the past, but Mitsubishi is teaming with ZeroAvia to convert some regional airliners, CRJ being one of them, to hydrogen propulsion. So is this going to be a quick thing, or is this going to just the start of a very long road for them?
I think the certification process on that would take a minimum of 2 years, just because you've got to, what you will do is you remove all the existing infrastructure, plumbing, pumps for the Jet A fuel that's in the aircraft, and then try to stick in some hydrogen tank and then plumb it to a new kind of motor, a power plant. So that's at least a 2-year deal from start to finish. It may be 5, honestly, just because there's so much happening inside the airplane, because you want to strip out all the now dead weight if you're not using the existing wing fuel system, and then put in weight somewhere else. Weight and balance will obviously be an issue. You'll have to flight test it. You'll have to do all the engine performance stuff you would normally do for the engine certification, and then do all the flight testing with the airplane to show the airplane flies. So this is not like we're just going to hook it up to hydrogen and go fly it. I don't see that at all. I think there's really you have to have a long-term vision of this, and you have to have a confirmed number of sales before you even start it, because you're looking at roughly, I'll spit out some numbers here. I think it'd be $100 million sort of effort to go do that by the time you're all done, maybe $200 million. So you'd have to have some customers. If you look at, I was looking at some numbers yesterday, these are relativistic numbers, about converting standard passenger aircraft into cargo aircraft. That's somewhere between 10 and about $30 million ish to make a freighter out of an existing airplane. It's going to be ballpark that to re-engine CRJ and put a new fuel system in it. It's going to be around those numbers. So pretty hard to recoup that initial investment unless you have some government assistance. I would assume that they do.
Yeah, and ZeroAvia is claiming that it'll be similar in cost to just putting new engines on it in general. I mean, does that strike you as accurate?
Yeah, it would. But see, there's no regulatory base for hydrogen. No. And because you're dealing with a new engine, new fuel system, new fuel, all those things have zero mean time between failures defined. It's really hard to design something like that without having thousands and thousands of hours of operating time. You remember that the engines we're using today are derived from things out of the 1940s. There's been a lot of changes, but you start build up reliability, right, through just service history and accidents and all those things. And you get to this really sweet spot we are right now, which is engine reliability is super high. You don't have that on a hydrogen engine yet. You have a lot more knowledge now. You have a much better computing capability to analyze, predict but still, you don't know what you don't know, Dan. And I think this is it's just a long. I still think it's a long way off. It just not saying it's not going to happen, but it's a long road.
Yeah, and that seems realistic. One thing you just mentioned, why does it cost so much money to convert a passenger aircraft to a freighter? What's the main drive? That seems astonishingly high, that 20 to 30 million.
So you got to cut a bigger door because you can't get those little cargo pallets into there. The floor changes, the structural change on the floor because you want to put those little rollers in there to slide the units back. It's got these locking mechanisms. There's a lot, and structural changes will happen to the aircraft. It may even re-engine the thing while they're at it to get better fuel economy. There's a lot of subtle changes, and each one of those changes needs to get approved by somebody: electrical, mechanical, structural. Right, and maybe there makes aerodynamic improvements. When you put winglets on it. All those things that make freighters much more efficient take time, and they're expensive. So I was shocked to see. I think it was a 777-300ER. The switchover cost was like in excess of $30 million. That's a lot of cash for Amazon.
Yeah, you think you just like throw boxes in, just like leave it as is. Just throw the boxes in the seats. Just pack them up, just put them in a seatbelt. Be way more economical than dropping that 30 million. But anyway, I digress. So moving on, the NFPA, National Fire Protection Association, is removing the requirement in Group 2 hangars for fire foam systems. And there's been a lot of criticism for these foam systems, but this is going to apply to Group 2, which is door heights of 28 feet or less. And a single hangar bay, less than 40,000 square feet. So, Alan, we've talked about this, I guess, probably close to a whole year ago now. But, I mean, why did foam come to such prominence and then fall so far?
Well, the insurance risk, the fire risk, you have this aircraft that's full of fuel, or even multiple aircraft that are full of fuel. So if one starts a fire, the other aircraft are going to go up. And when you get into a Jet A fire, it's not fun. So the risk is really high. I mean, once you have a fire, the risk is really high. I think what's happened is that the aircraft are better designed now. And everybody's super aware that you can't mess around in fuel systems and have fuel everywhere. The cleanups are a lot better. Like one of the things that used to happen a lot was the fuel would, if you overfill an airplane, the fuel would come pouring out the vents on the wingtips, and so it's like dumping fuel, and that would occasionally happen in a hangar if you overfilled it, stuck it in there, and it got warm. So I think everybody's just a lot more aware of the fuel risk, and there's also a lot more monitoring systems on in hangars than there used to be, cameras and that sort of thing. And we're having so many, I think the real issue is having so many of these systems go off without a fire, and they're super expensive to clean up, and the airplanes are damaged. Not so much they could show like that foam is going to cause damage, but all the manufacturers around there don't really know what's going to happen to the lifetime of a brake, a wheel, a tire, wing, paint, boom, 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 boom. So everybody kind of wipes their hands of it, and it just ends up to a costly repair. And that didn't seem right to a lot of aircraft owners, that you made me put the system in. We're never going to have a fire. We're super careful. And yet I got a damaged airplane because of the thing that was supposed to save me money on insurance. Didn't make a lot of sense. I think that's right. And it's good that the insurance and NFPA are working together to remove that requirement. Where if you don't want it, you sort of take your own risk there. But airplanes are designed a lot different and a lot safer than they were 30, 40 years ago. They just are.
Yeah, and of course, these hangars that are now exempt from having to have the foam are not able to do fuel transfer, welding, torch cutting, soldering, fuel tank repairs, spray finishing, stuff like that. So again, as long as you're not doing those higher risk activities, you don't need the foam. That seems to definitely make sense. And you're right, that idea that if this accidentally discharges, or if it discharges rightly, it's still like a catastrophic event. That's what's so crazy about it. It's like the sprinklers going off in your home and it ruins everything that you have. It's just like, well, might as well let the fire burn. Obviously
There's more water damage, than fire damage. I think in the case of a house, I think this is also part of it. Is that when you go to an airport, the hangars are spaced apart from one another, rightfully so. So if you did have a fire, what you're trying to avoid is catching the next hangar on fire. It's like a house. If the house catches on fire, that's bad, but we don't want it to get down into the neighborhood. So we want to have essentially fire breaks or things to slow it down so the fire department can put it out before it gets to the next house. Same thing with hangars, before it gets to the next hangar. I think what they're finding with the steel hangars and the things that they have, the fires are not escaping.
Yeah, that makes sense. Also, like firework campuses, they always have all the different things in different little sheds, different little buildings, so they can't blow each other all up. So, yeah, social distancing.
Gone are the days when you could walk into a hangar and see flammable fluids just sitting around. They're in fire cabinets now. If you walk into a hangar and see Jet A, a can of Jet A sitting around, that's really abnormal because everything's in basically a flame-proof can, or it's stored away safely. So when I was a kid, that wasn't always the case. You could walk into hangars and there'd be oil and all kinds of solvents, paints, and Jet A, avgas, just kind of out in the open. That's all gone away, and rightfully so. Come on, I mean, it's just there's just too much risk of fire there. So we've gotten better. We've just gotten better.
So moving on, the FAA has about 100 aging control towers for air traffic control that are going to start to need some updating. So obviously, I guess a lot of these airports in general are now starting to age, Alan, and I guess as we've seen a lot of airports get updated, perhaps a lot of the other infrastructure like the air traffic control facilities haven't. But it sounds like a lot of this is now coming due, which is an expensive proposition. I mean, you hear about these all these infrastructure things like here in the Northeast. They talk about tunnels with like Amtrak, for example, and there's one that was in Baltimore that was just like a known issue that it's getting to the end of its useful life. It's starting to bottleneck, and just talking about the expense of it, like, yeah, this would be like a $6 billion project to replace this tunnel, and you're like, good grief. But my only point in that is just like there's a lot of stuff in America that was built 50 or 100 years ago that's now coming in need of a refresh. So like this is probably a growing problem, and 100 of these control towers is not a small amount.
No, it's not, and there's a lot of requirements put upon those control towers, which adds to the cost. When you see a control tower, usually it's the tallest thing around normally, because the controllers want to be able to see what's going on around them actively and put some eyeballs and binoculars on it to check out what's happening. So they tend to be very tall. And of course, when the taller they are, the more expensive they get. And then the more structurally rigid they need to be. Like if they're down in New Orleans, you got, hurricanes, Alabama, Florida, they're going to have a bunch of hurricanes down there. So there's a lot of requirements put on control towers. And much like your iPhone, all the infrastructure has changed dramatically over the last 10, 20, 30 years when the tower was built, right? So if you can think about just the computer systems and all the infrastructure that happens there, because the control towers are more complicated than they've ever been in terms of technology. So, you just basically age out of a building. That's what's happening. A lot of FAA buildings are kind of like that now. Like you're saying, most of them are probably 50 years old. So what do? Well, now they're trying to, and the interesting part about this is they're trying to make the control towers essentially what we call net zero or true zero. What are we calling that? Where they create all the power they're going to use from solar panels.
Yeah, I guess net zero, whatever they would need.
Yeah, so if it's net zero, like I don't know if you looked at the control tower in Tucson. It's being used as the foundation for this, but they use solar power to provide the power for the control tower. But any excess power they create, they make ice. Did you see that? They make ice. Like, do they have just like a big ice maker in the bottom of this tower, and they're just blowing air across the ice so that they don't have to provide so much cooling? That's how they sort of store energy is in ice. I've never seen that before.
Yeah, I don't know. Yeah, I don't know if they're running an ice maker with the electricity or if they're doing it in some sort of the way like the Sonovate, that Australian startup is doing it, where they have, I don't know, you don't think there'd be enough energy there to make ice, but There's some cooling effect that they get from their panels, but yeah, that's pretty interesting. I mean, that seems like the old like Abe Lincoln-esque air conditioning where you're making ice and just like blowing air over it, which I mean, I guess works. Yeah.
It does work. It's cool. Obviously, it's cool air.
But yeah, they're using a lot of different tech to, all the reflective roofing materials, really well insulated windows, motion detectors, all that, just you're not wasting energy if you're not in a room. So, um, yeah, it's going to make sense to do a lot of these and save money that way, and also I'm sure just be a lot more efficient for people the way people work today. I don't know. I mean, do you feel like I'm sure they've obviously gutted a lot of these over the years, but at some point you just can't keep gutting it and get the efficiency that you need to meet modern demands.
Right. Systems age inside the towers. You can imagine the environmental control systems, the air conditioners, the heaters, and all that stuff just get old. The plumbing gets old. Everything ages. It's like an old house. Problem is, there's a bunch of airplanes that rely upon you, so you can't really have it go down. And I think that's just it, right? There's just a useful lifetime to these things that I think we knew when we built them. There was a useful lifetime to them. Probably was 20 years, maybe 30 years. And we're probably, like you're right. You're probably right, Dan. We're probably pushed it to 50. And it's probably time. Well, that's good because that's a function that is desperately needed. And you have to have those there to have safe operation at airports. So it makes sense.
Well, here's the question. When you build a new one, you obviously have to keep the other one in operation before the new one's complete. But if they're the same height, then one of them is going to obscure the other. So do you have to build the new towers taller so that when it's ready to go, it's above the old one before they can raise it to the ground?
I have seen these temporary control towers. I think they were developed by the military. Because if you imagine you're in a military operation, you're making an airport in the middle of the desert or forest or whatever you're at, and you need a control tower. They have these little pop-up control towers. I've seen those used, and I don't remember where. It may have been in Nebraska or somewhere. Maybe it was Arizona. And you're right. I think the tower they have temporarily is shorter while they try to rebuild or build new, a larger tower. I think also the advent of cameras also helps to monitor what's going on at the airport. So I think what they're doing is also installing cameras. And other thing to remember now is the airport is a lot more secure after 9/11. So you don't have as much risk of like people driving onto the airport property and animals running around because it's all kind of fenced in now. So and it's monitored. So I think there's probably a lot more technology at an airport than you would really even conceive of until you got there. But I wonder if the towers need to be built as high as they are if you're just using binoculars. It's a good question. I don't know.
Yeah, because it's not like a typical building where you can just hang out in the new building until the next one's built, right? It doesn't matter. Just shuttle over there when you're done. But with this, I don't know. I mean, I would assume that the strategic best position for a control tower has probably changed also as routes have changed. So perhaps in a lot of these instances, yeah. So perhaps in a lot of these, like they don't even want the current location. It's 50 years old, so they might be moving 100 yards down, across the airport or across the tarmac or whatever. Yeah, I don't know. Maybe it is. In some cases, it is the best location in that sense. Then it becomes kind of complicated about where do we post up without having, because if you have a temporary control station, you've got to change so many different processes for a 2-year period as they build this new tower. This seems like a really big disruption, different than another just regular type of building where visibility is not important because, again, a hospital is going to go on its business until the new hospital is built. Then they'll move over. Like, okay. But it doesn't seem like quite the case with this. So, that'll be interesting to see how that evolves. So last year, before we hit our eVTOL segment, is Blue Origin. They are trying to take you to space and have you hang out there in their new business park called Orbital Reef. And of course, this would be super expensive. And I don't know. I mean, a lot of these space things, are they inevitable? We got to get started on them now and start thinking about them now. Is this really a realistic thing? I don't know. I mean, how does this strike you, Alan? Does it seem kind of a little bit out there?
It's a little out there. Some of the comments I saw online, well, I hope Bezos goes first, right? It's like, get him off the planet. Like, wow, that's a real big anti-Amazon push at the moment. I'm not sure what that's about, but yeah, I don't quite get it, right? Is this just to balance off what Musk is doing or about to do on Mars? Is that where this is going? I don't understand the ego bit of this. Do you? Do you like Musk and Bezos are like constantly poking at one another? And I'm not even sure why, but then, like, for what benefit is this? I don't understand the business park in the sky concept. I don't necessarily understand the Mars thing. Maybe in general I do. But there's just like this weird dynamic. It's like we're in the late 1800s with the railroad magnates. They're clashing about some stuff that me and you, Dan, are never going to see or even care about. But for some reason, it's just like this little bit of a tete-a-tete ego thing that's happening. It's just very odd.
Yeah, I mean, this idea that there's going to be a quote unquote vibrant business ecosystem growing in low Earth orbit, generating new discoveries, products, new entertainments, and global awareness. That seems crazy. Now, I'm sure a lot of people wouldn't mind hanging out in low Earth orbit for a while because you're in space. Like, how cool is it to be in space, right? But I don't know that you're going to, I don't know. It seems limited in its scope, like how much work is going to go on besides like research. I don't know. What are you going to be developing? And I realize that if you're going to colonize Mars or any of these other planets, you probably need to do some of that work in space to have an idea of what the demands of certain things are. I don't know. I mean, if you're going to develop the next Mars toilet, do you need to do that while in space to know the demands of, urinating in a Mars in a zero-G toilet? I don't know. But yeah, this seems like, in general, I'm not one of those, obviously not one of those people who's shouting down the billionaires just wasting money while we have problems here on Earth. But this does seem like a good example of that, where this is kind of dumb. Maybe let's put this towards hunger and poverty and not a space park. I don't know. It seems.
You know who the first tenant's going to be? It has to be Starbucks, right? It has to be Starbucks. Otherwise,
Or pumpkin spice latte that's slightly too sugary.
Yeah.
For sure. Yeah. Well, we'll see how that develops, but I mean, here's the thing. It says NASA plans to allocate 400 million to start construction. So this isn't this isn't completely without merit, or at least without backing. I don't know if backing equals merit, but there's some backing. So, and obviously like research and all that stuff can certainly go on. So maybe NASA just is like, hey, we want a wing of this. We want a chunk of this to do NASA things. Makes sense.
And the space station sort of thing. And maybe, space stations are billions of dollars, right? And clearly. So, yeah, it may be cheaper for them to rent than to own.
Yeah, but you just got to wonder how much. I mean, if people are hanging out in space, like how much does it cost to feed a person in space for a month? I mean, like when you start to.
A lot.
I mean, like so much money. Yeah, I mean.
Yeah, you're launching it up there.
Yeah, it's hard to conceive of the benefits and just do a cost benefit analysis of something like this. It just seems impossible. Moving on to our eVTOL segment. So this is a new one-person eVTOL. It's called the Jetson One. Retails for $92,000. And they're a Swedish company. Is that right? And yeah, this is similar to the sort of Russian hover bike that we saw that crashed, that man somehow stumbled out of completely unharmed, despite having propellers spinning right next to his thighs. I mean, that is one of the luckiest humans on the planet at the moment, if he's still kicking around. But this has a similar design. It's got a roll cage, so it seems safer than that. And they show it flying around. Seems like relatively stable. Has some crash obstacle avoidance technology in it. Goes 62 miles per hour, I believe, and has a maximum capacity of 210 pounds. So moderately sized humans only for now. I mean, Alan, what are some of this is obviously something that you can, is this qualify as a light sport aircraft, or where does this sort of qualify as far as the certification?
I think because it's so lightweight, it's an ultralight, which just means you can just go fly it. There's no physical medical requirements or a license required to go fly this thing. You sort of users take their own risk. You just can't fly near civilization. That's one of the requirements on an ultralight. Have you ever seen an ultralight zipping around? They tend to do it in places where there's, fields and trees and that sort of thing, not overpopulations, and that's why. But the technology is kind of cool. Like the idea is cool. Putting into practice is pretty cool. It'd be fun to zip around in this thing. But again, I just don't know if there's a marketplace for it. Maybe if we're in the desert and there was nothing to run into, I could see it. I don't know, you're just flying around sand dunes, or you could be out in Arizona. Those kind of things that make sense. Any place that I think there's a tree, I'd just be really leery of this because you're not flying that high and landing's a problem. And so I think there's limited applications for it. But the home kit market, and this is what I would call this, is a home kit sort of thing, was huge in the 1970s and 80s in the United States, and it still is fairly large in terms of people building their own aircraft. It's a big industry, and the price point is probably right. A lot of the kits are in the $100,000 to $200,000 range ish by the time you're all in. So being at under $100K for this thing possibly could be a little toy to jet around in, and like you said, it's going to be used like that as a piece of entertainment. Probably not going to and from work. You can't in it. So it's cool. You got to wonder what the next step is, right? Once you get past that initial sort of single person fly around droney thing, what's step 2? Don't know, right? Because the population centers are in cities. Those are your buyers because they have the income probably to do it. Yeah. It's cool, but it probably won't get that far, unfortunately, unless they got another step somewhere. Like this is just the initial step, and they go into plan the bigger scale, what this thing is, and then expanding out to make a real business out of it. We'll see. It's cool.
You said, so for this sector, the light sport where they have, you say light sport or experimental, they ultralight. So, I mean, what do other companies that make ultralights do? How do they make money?
To keep things really cheap and inexpensive and keep it simple, and the user takes all risks sort of thing. That marketplace is not very big.
Do they have a bigger business? Like you said, I mean, do most companies that make these ultralights also have a bigger aircraft or something else that sort of sustains the business? This is just like one product, or do they only do ultralights?
No, yeah, they tend to stay there. There's a sweet spot there.
So some companies can make it work financially, but it's just harder, I assume.
You don't, and here's my take on it. You don't see those businesses last 30, 40 years. Typically, they tend to be 5-year, 7-year. Like if someone will get really interested in the technology, well, build one for themselves and realize, hey, maybe I can build 10 more. 10 of my friends will buy this, right? And they do that for a while, and it's fun, and it becomes like a hobby, right? It's like radio control airplanes. It's kind of that hobby stage, and it is fun and enjoyable, and people really do enjoy it, and they get a lot out of it. But then life changes, and you don't want to do that anymore. You move on to the next cool project, and it's sort of cyclical like that. But you got to say there's been a lot of technology changes that have happened at that level because it allows you to play around. Different materials, different designs, different motors, all these different things. They let you play around, and you become sort of part scientist, part engineer. I never think that's bad. You could learn some things out of it and maybe change the way we do other things. So a lot of technology that you see, like at Boeing today on the 787 or the new 777 or the Airbus for that matter, that's really started down at the sort of homebrew kit market, carbon fiber, fiberglass. You just got to start small. This is that same sort of industry. And maybe this little, Jetson drone is sort of that same sort of thing. It just seems like it takes forever before you get to sort of a commercial stage that you and I would be using.
Yeah. Because right now, I mean, you look at who would have the money for a $92,000 aircraft that they've got to throw on their trailer, haul somewhere off the grid to then fly around. So then, all right, maybe someone who has the money to have a, ranch in Wyoming or a ranch in the desert or some where they can keep this, along with a couple, They got some ATVs. Like they have that whole sort of like fun stuff to do on our remote house kind of package. That kind of person, might own one of these. That would seem to make sense. They can just like pull it out. It always stays in the ranch house, right? Um, but that seems like a pretty small sliver of the population. But like you said, if that is there's enough profit built in to each of the builds where it makes sense, they make a good chunk of money selling a handful of them here and there, then yeah, but that makes sense. I hadn't really thought much of that market, but that you're right. That's a tougher way than having like the full commercial viability where anyone, no matter where they live, can buy and use this. Which of course that's not really the case with aircraft in general, right? But it could be a sports car. You can live in downtown LA, buy any sports car you want, put it in your garage, and you're good. But if you live in downtown LA, you have no use for this unless you're going to put in your trailer and go out to somewhere every weekend, which is eventually going to be a thing where you're like, I don't feel like strapping this thing to the trailer again, right? I just wish I had a place to put it.
Yes, that's what happens. It's exactly what happens. And if you look at, it's like owning a boat or a dune buggy or that sort of thing. They're a lot of fun for the time you have them, but there's a time you just kind of grow out of it or find something more interesting at the time. And that's what happens. That's why it's so cyclical, I think.
Yeah. Well, speaking of grown-up things, let's talk about insurance. The super important thing that's not very fun, but keeps you from being bankrupted. So Alan, really good article on flyingmag.com just about EVTOLs and regulations, and there's some good perspective from a lot of different underwriters and brokers in this article. What were some of your takeaways? I mean, this is a budding industry, and there's going to be a lot of unknown risks, and they don't really know what the use case is going to be. What are some of your takeaways from this article, and what do you think some of the insurance challenges are going to be?
Well, just stepping outside of this for a moment, in any sort of new aircraft market, the risks appear to be really high, and what tends to happen is you have there is a marketplace there, right? So all the assurance adjusters, actuaries all come in and go, we can make X amount of dollar if these conditions are met, right? And so they try to form this marketplace. And it's hard to think about it that way, but there are insurance marketplaces, like going down to your local grocery store. It's a marketplace. They all actually created out of whole cloth. Like, what does this marketplace look like? And what are the potential risks, and where do we put boundaries in it, right? And the aircraft side, because the FAA is involved, it sort of lowers that threshold a little bit on terms of, there's some minimum standards that all the aircraft will be built to. So it's unlike the home kit market. You're not exactly sure how everything's built. In this particular case, you have a pretty good idea how things are built. So it reduces the risk. I think what's going to develop, though, is like some of the airplane companies used to do. They used to self-insure on the aircraft side because it was less expensive. And at some point, you're like, if we get sued for $1 billion, guys, this is over anyway. So instead of me paying premiums and going bankrupt, we'll just take the downside risk that if there's some huge catastrophic event, it's over and we're going to go home. So you get to that kind of marketplace. This is the weird thing about this on the eVTOL market is the Uber part and all the large, financially wealthy, in theory. I don't know if Uber actually makes any money yet, but in theory, they could hold a lot of cash, and so they'd be very vulnerable to being sued. So I think that's where it comes into, like, where do the aircraft companies who have, some of them have $1 billion of value right now, do you actually want an insurance product, or are you just willing to like take the risk and just hire a bunch of lawyers? Maybe cheaper. So you see how that plays out, because it's a risk. It's a balancing of risk, and airplanes are risky. Any side of airplane is risky, as we learned on the 737 MAX. Right. Very well-known, recognized airplane company with thousands and thousands of engineers gets tied up in this, and which, and there was some possibility early on, could have really broke Boeing. That plus the pandemic could have really hurt them if they've got hit for several $billion. I think that would have been a big, and they probably got hit for probably $1 billion in terms of losses. It can break a company. If a company like a Joby or a Kitty Hawk or a Whisk or Beta, it's up here near us. If they get in that situation, it's kind of over, right? Airplane catches on fire in the sky. It's in Los Angeles. Some famous basketball player happens to be in the aircraft. When that happens, wow. Market collapses. What are you going to do? Is it even worth having insurance? So I think that's where everybody's going to try to figure this marketplace out. And you have a lot of early entrants into it, people who know it, and they're going to have those big risk takers on the insurance side because it's just a pile of cash, right? There is a lot to go yet in that marketplace. Just a huge amount to learn in that marketplace because we don't have any aircraft that's close to being certified yet. Don't you see that? How that plays out? There's just so many variables to it, and at some point, you got to do due diligence and say it may be worth an insurance product, and maybe not worth an insurance product. Good question.
Yeah, it's especially again without knowing what common risks are. I think the other thing they brought up in the article is that pilots, how well trained are the pilots? Like at first, pilots aren't going to have a whole lot of flight time on these, right? So I don't know, does simulator time count just the same as actual flight time? I would assume probably not, but I don't know. So yeah, just like everyone's going to be brand new, so a lot more mistakes will be made, a lot more there'll be clunkier, reporting, just all the safety procedures get honed over time. Like you said, with oil cans and Jet A fuel being out in the hangar years and years ago, well, people learn their lessons, but until you have a lesson learned, you don't have a lesson learned, right? So there'll be little things that they'll figure out as they go that'll be higher risk early and lower risk as each year goes by. And you get people in there and say, oh, we need to do it this way. This makes more sense. This is clearly safer. We can, streamline this, and this. So yeah, that'll be interesting.
That's why you have the NFPA and the fire codes, and that's why you have the FAA involved, and that's why you have other pieces which are almost insurance pieces. The FAA is kind of like an insurance piece to speak of, in that it provides confidence. Right? Insurance is about confidence, and risk is confidence. So as the marketplace starts to come together a little bit, we have a better sense of what that confidence is. But the insurance agencies and the insurance approach can actually drive what happens on the safety side somewhat, right? They can put limitations on how the aircraft's going to perform, or in some cases, they may require additional training. They may, the kinds of riders that come on the thing may be different. So the insurance companies are pretty good at mitigating risk. And so they can add extra things like in the hangars, like when they go and audit a hangar, they don't want to see a bunch of Jet A on the floor and a guy smoking in the corner. That would be bad, right? So that's going to raise your rates. So companies don't like to do that. And so you can think about the insurance companies and the risk. They try to drive down the risk to maximize profits, but at the same time, driving down risk also improves safety. So it's a sort of a double-edged effect. It's interesting because I think this market is so dynamic right now. We're not sure where it's going. And spending too much money on insurance is not going to help you. Spending too little maybe not be helpful. Or spending it all may be the best thing. Who knows?
Well, that's going to do it for today's episode of the Struck Podcast. Thanks so much for listening wherever you are on Spotify, iTunes, Stitcher, YouTube. Be sure to leave us a review, subscribe to the show, and we will see you here next week on the Struck Aerospace Engineering Podcast. Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.